Alright, hey everyone, it's been years since I made my last video. I've decided it's been long enough, let's just get this video out. And it's been so much time that like a lot of 3D print stuff has improved since then, but back when I made this, it was way faster than normal printers. And even to this day, like I have a Bamboo Lab X1 Carbon. For certain geometries and shapes, this is better, faster, for certain use cases than the X1 Carbon. And like back then, before it existed for consumers, this was like insane, and I was really excited to show everyone, but I've just been so busy doing my own stuff. But here we go. I have made a rotational 3D printer that can make really cool things such as springs, this is a double spring. No, this is actually a triple spring. 3 springs in one. This single spring, wave springs, and it can even make screws. And these are different because normally with a normal 3D printer, the layer lines prevent the screw from like really being really smooth. But this, you can see like just how smooth this is. And that's because when you're doing it rotationally and it's building up these layers in this direction, they're smooth layers. You can see how smooth the screw is. And you can even build functional things like rods. And these rods, I'll go explain why this printer is so cool, and then come back to that. But these rods, because the print lines are like parallel, the cleavage, like the plane of cleavage where it would break, you would see like normal 3D printers, they'll break right along there because the layers are weak. Because these layers are in line with like how you bend the rods, these rods are so strong they can support my body weight, particularly this one. And I've even tried getting them really thin, and even the thin rods will support my body weight. I had a video of like me and my homeboy testing these, but maybe I'll include that at the end or something. I just want to get this video out there. So let's take a look at this printer. Total mess right now, but basically I modified a Creality CR10 because I have 2 CR10 V3s and the Bamboo Lab. I don't really need an old CR10 anymore, and this is like the first CR10 from 2017. And let me just flip the camera. It's just a modified to have direct drive, normal stepper motor at NEMA 17, but with the CHT nozzle. And the cool thing about this is, why was this printer so slow? Not just because it's a bed slinger limiting its acceleration, but just acceleration. When it has to accelerate back and forth, you're not hitting that top speed. But when you're doing a rotational shape, which I'll have videos later, you can spin this at top speed, and as long as you're not changing direction, you're not gimped by acceleration, you're gimped by top speed. Speed and acceleration are different things, and that's why the Bamboo Lab is so fast, because they have that 20,000 millimeters per second something acceleration. But here, I've got 3-to-1 gear reduction, so for every spin here, it's 3 spins here. So this can spin pretty fast, and the only limiting factor is the melting. So with the CHT 0.8, we can get really high speeds with just cranking plastic out as fast as possible onto this rod. And I'll have some videos of that later. So for certain shapes like rods, screws, discs, and anything that can be printed rotationally, I wrote my own software to like make these shapes. And that's the cool thing about being a software engineer. Like if something you want to invent doesn't have software for it, you can just make it yourself. And there's other shapes too, like you can make these gear shapes and the spring. And there's a really cool thing, I made a little flag here to display, like when you have this profile of spring and you move this up, you can actually convert some of that back and forth motion into rotational motion. This is a little, there we go. You can see that the belt is moving, and I thought maybe that might be a cool mechanism one day, but this can even rotate that, so you can make gears with this thing. Anything that can be printed on a rotational axis, you can do it really fast at the speed of which the plastic is being melted. So I did some tests, like a solid rod on the old CR10, like V3, would take 4 hours depending on the rod. And then running it on my custom printer, it only took like less than an hour. I think only a few minutes because of that rotational motion. You're not gimped by direction changes. Only twice at the end. So if you're printing solid rods, you can get these really fast, and you can even like make couplers to make like bind 3 rods together, make right angles and stuff, and make it really strong. And the cool thing is, there's so many cool things. So I'm printing on a 8mm rod. You can also print it on a 16mm rod, and just by changing out the rod sizes or even 3D printing substrates, you can do lots of sizes, and you just have to tweak the software settings to let them know where you're starting. And the cool thing is I could do that with the software. You can do all kinds of shapes. If you're making discs, this thing will just spit out discs really fast. And one of the problems I ran into was like getting prints on and off, because if you're printing and these rods are directly on the metal, they stick. So I made these liners with my top-down projection printer. The diameter is slightly smaller than the rod, so it clings to the rod just barely. And when you print on it, all of that plastic will stick to this really well, and then you just pop and it comes off the rod. And so you can print all you want on top of these liners that are less than half. These are 1/2 millimeter thick walls, and the nice lattice shape provides a lot of area for that plastic to grip on, but not to like stick to these metal rods. And so you can get the prints on, get the prints off. It's really cool. What else? You can have ironing, so the surfaces of these are really smooth, and you can set this ironing however you want, and since it's all in one direction, it looks really clean. And the next thing is you can have infill. You can generate infill, and with that you can make these shapes really, really fast. And now I know a lot of you guys are gun enthusiasts. I know that you will immediately know what this is. This is a gain twist barrel. The twist, or a progressive twist, the twist at the beginning is like this much, but right before it gets steeper and steeper, so the projectile has time to accelerate up, so it's spinning slowly, and as it gains speed, you can gain even more speed. So using a progressive twist, you're not straining the lands of the rifling. The rifling progressively gets more aggressive, and you can get way better spins with different ratios if you can tweak it using a progressive twist. And using this printer, you can produce progressive twist barrel rifling. The next thing is like, I made these super beefy springs, and I also made this thing so you can slide 3 springs. This one's a little oversized, but you can put springs into this and like load multiple springs in parallel. And if you have enough springs loaded in parallel, you can make an air gun with a ton of power. This is like several I think this is 2 millimeters thick PETG. It's pretty tough, and you can launch things with this. Like you can launch washers and stuff, and it has some force to it. And the magic thing is, if you can get a 20-to-1 compression ratio, you can actually ignite ether. And when you're doing that, let's say you live in a place where you're not allowed to buy ammunition and propellant or primer, you can go out to the hardware store, get some ether, hit that 20-to-1 compression ratio, and you can lower even further. Depending on your ether, it's like a 12-to-1 or a 20-to-1 if you're using like straight up diesel. You can actually propel something past the speed of sound. And one of my projects was trying to get these things to break the sound barrier. But then I realized even using ether and not just powder is illegal in the state of California, so I did not even test it. I did not even try. But if you have propellant, which is legal to own, not to use, just to own, and you ignited it with this, you no longer need to buy primer. You're one step closer to being able to make your own propellant firing device with one less step in the supply chain. And despite all of that, as long as you have either, you can break the sound barrier if you're shooting like tiny projectiles. So if you combine the plastic springs with gain twist rifling and put these springs in parallel with ether inside your projectiles, zoom, you'll be zooming like 1,000 feet per minute, per set, whatever the unit is. The speed of sound is 1,200 something, but that's the magic of this stuff. And it's you can make so many cool things, and I've just had barely enough, I don't even have enough time to pursue these things, but I thought this was really cool, and hopefully you will think it's cool too. What else is there? That's pretty much the whole video, but maybe I can share some more cool things, like this wave spring. You can have like twice the compressive force, or twice the compressive force of an equivalent like normal spring in the same amount of area. And if you make these out of TPU, they're fantastic dampening springs. So if you're like dealing with slide bashing, you can have a really small wave spring made of TPU, and as it compresses down, takes some of the force away, and once it bashes, it's that compression of the TPU that will prevent slide cracking. So there are so many cool possibilities with rotational printing, and it's just a simple mod. Like, I printed the brackets, put in some ball bearings, and got the rod, wrote the software, and it was pretty cool. So that's pretty much it. This was an idea that I thought was super cool, and I hope someone out there finds it cool too. And anytime you need a spring and you have a cute little spring printer, or you need a rod, this thing will make these high quality springs for you. And as long as you don't need like tons of force where you might need multiple plastic springs, and this is great. And even like if you're working in the electrical business, plastic springs don't conduct electricity. And depending on like your purposes, you just need to stop a load, you can make some of these wave springs. There's just so much practical application to this, and that's what I think is really cool and is missing from 3D printers, is that practical application. But that's it. I'll see you guys in the next video, which hopefully soon. I have a bunch of ideas, I just need to find the time to do them. See y'all.